In this lesson, we are using the distance formula that we learned in the previous lesson. You see I've already written it down on this screen. We're using the distance formula in order to find perimeter and area. And in this particular problem, they didn't give us the coordinates of the points, and so you'll see that I've written them in. And how this all comes together is realize that the distance between 2 points is the same as the length of the segment connecting those points. And if we remember that perimeter is the sum of the length of the sides of the figure, then you would realize finally that we have to use distance formula to find the length of RS, find the length of ST, find the length of RT, and then add them all together in order to find the perimeter of the triangle. And yes, of course I realize how cumbersome it is. I'm about to do it for you. But you'll see that the assignment for this lesson will naturally be considerably shorter. So, we start by finding the length of RS. That's the square root of, I follow my formula. Formula says, open parenthesis, subtract my x's. So when I subtract the x's in RS, I have -4 minus 3 squared plus, formula says subtract my y's, so that's what I do. And then we clean it up. -4 minus 3 is -7. Remember that when you square a negative number, it becomes positive, so -7 squared is positive 49. 1 minus 3 is -2. Same thing, it's going to be positive. -2 squared is 4. Add that together, I get square root of 53. And you type that into your calculator, and you get approximately 7.3. And then you move on to the next segment. Segment ST. Square root. Subtract my x's. 3 minus 1 squared plus subtract my y's. That's 3 minus -3. Remember that minus a negative becomes plus positive. And then again, clean it up. 3 minus 1 is 2. 2 squared is 4. Plus 3 plus 3 is 6. 6 squared is 36, so I have the square root of 40, which I go in my calculator to take the square root of 40, and I get approximately 6.3. And then finally, the length of segment RT. The formula says subtract my x's. So, -4 minus 1 squared plus, formula says subtract my y's. 1 minus -3 squared. And then I clean it up. So we have the square root of -4 minus 1 is -5. -5 squared is positive 25. Plus, once again, remember, minus a negative becomes plus a positive. 1 plus 3 is 4. 4 squared is 16. And 25 plus 16 is 41. Take the square root of that. And that's 6.4. Oh my goodness, that's a lot of work, but don't forget why we're doing it. We were asked for the perimeter of the triangle. That means we add these 3 lengths together. So finally, in order to get our answer, we do 7.3 plus 6.3 plus 6.4, and we get 20. units. And that's that problem, finding the perimeter. In this problem, we are told that this is a rhombus. Remember how you find the area of a rhombus. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. So we see in our diagram that segments AB and CD are the diagonals. Once again, we're going to use distance formula. This time we only have to use it twice. And once again, they didn't tell us the coordinates of the points, so we have to identify them. A is located at -3, -4. C at -2, 3. B at 5, 2. And D at 4, -5. And here we go again. Let's take this formula and copy and paste it. And be mindful not to mix up your D's. The D in this formula is for area, and the D's represent the diagonals of the rhombus. The D in this formula means distance. Two totally different things, but we're using them. We're using this D in order to find these D's. Okay. So, CD, gosh, that's a lot of D's. Square root. Subtract my x's. -2 minus 4. Squared plus subtract my y's. 3 minus -5. Squared. And clean it up. So that's -6 squared is positive 36 plus, once again, remember this, 3 plus 5 is 8, and 8 squared is 64, so this is the square root of 100, oh that's nice, that first diagonal is 10. It's the same process to find the length of AB. Square root, subtract my x's, squared plus subtract my y's, clean it up. Again, minus a negative becomes plus a positive. 5 plus 3 is 8. 8 squared is 64. Plus 2 plus 4 is 6. 6 squared is 36, and this looks familiar. That's the square root of 100, which is 10. So remember why we did this. We did the distance formula to find the lengths of the two diagonals. We have found them both to be 10. Area, therefore, equals 1/2 times 10 times 10, which is 50 square units. Pause for your turn below. In this problem, we're being asked for two separate things, finding the area and the perimeter of the triangle. And even though we're being asked for two things, I think you'll find that you'll eventually find that this problem is quite a bit easier than a couple of the previous ones. The reason why is notice that in this triangle, LM and MN are a vertical and horizontal segment respectively. Remember, we talked about it in the previous lesson that when we have a vertical segment or we have a horizontal segment, we can find those lengths very easily by just counting the spaces. So the length of LM, just by counting the spaces, is 1, 2, 3, 4, 5, 6, 7, 8. The length of MN is 1, 2, 3, 4, 5, 6. And two different ways you can approach finding Ln. Since the right triangle has already been drawn for us, we could use Pythagorean's theorem in order to find Ln. If you recall, Pythagorean's theorem is where the distance formula comes from anyway. So let's go ahead and do that. Let's make our life a little bit easier when we can. So Ln squared is going to equal 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36, so Ln squared equals 100, and when I take the square root of both sides, Ln is 10. Okay, but keep your eye on the ball. The problem isn't asking us for the length of the segment. The problem is asking us for the area and perimeter of the triangle. Well, we've just found the 3 lengths of the sides of the triangle, so it would be very easy to find the perimeter. We just have to add those 3 numbers together. So perimeter is going to equal 6 plus 8 plus 10, or 24 units. In order to find the area of a triangle, I would hope that you'd remember from the previous cluster of units, area of a triangle is 1/2 base times height. And in this right triangle, the legs are the base and height. So 1/2 times 6 times 8 equals, oh, look at that, that's also 24. This one is units squared, however. Pause for this your turn.